All right, here we go. We got area volume problems, starting with 2019. Number 5. All right. I don't like starting with this question because I prefer starting with a calculator question. This is a non-calculator question. It's a good one to do anyways. Find the area. Okay, so I need an infinite sum. It makes sense to do vertical rectangles. I remember it's like a infinite sum of the height of the rectangle times the width. In this case, the width is very skinny x dx. The height of the rectangle is a y top minus a y bottom. And to figure out which one's the top and what's the bottom, looks like if I plug in 0, this is 4. If I plug in 0, this is 1. So this is the top, this is the bottom. So I got to do 6 minus 2, x minus 1 squared is the top minus the bottom. Negative 2 plus 3 cosine pi over 2x. Summing up these vertical rectangles from a leftmost point to a rightmost point, 0 to 2. Fortunately, or unfortunately, we need we need to do this by hand. Now, do not plug in 2 into this and plug in 0 into this. Newton would roll over in his grave in Westminster Abbey. You know you have to take the antiderivative, then plug in 2 and plug in 0. You may want to simplify first, but you don't have to. And the key for any non-calculator question is you don't have to simplify. So maybe we just take the antiderivative. 6x minus this is x minus 1 cubed times a third, so that's 2/3 minus is negative 2x. Antiderivative of 3 cosine pi over 2x is 3 sine pi over 2x, but times 2 over pi. That's the whole multiplied by the reciprocal of the coefficient of x when you're taking an antiderivative. So it gets 6 over pi. You would then include a plus, so you don't have to plug in 0 and 2. Now, guys, it's a calculus test, not a arithmetic test. You can literally just plug in 2, and I mean it's easy enough to know that the sine of pi is 0. So that's 2 plugged in, and then plug in 0. This is 0. This is minus. This is negative 1. So this is positive 2/3. And then I have a minus, and then that's 0. That's 0. So that's it. This is easy enough to do without a calculator. Hold on. I'm subtracting this. Wait, where did the negative 4 come from? Oh, that's plugging 2 into the top. Okay, so minus negative 4, that's good. And then minus in parentheses, plugging in 0, I got that positive 2/3 in there. Okay, so that's plus positive. This is actually easy enough. You can leave it like this as long as you plug in the numbers. 16 minus 4/3. What's that? Just leave it like that, whatever. All right. Region R is a base of a solid. Each x, the cross section perpendicular to the x-axis, has an area of this. Here's why this question is tricky. Usually it's like, oh, we're putting squares. It's like, what's the volume if this is squares? What's volume if this is a triangle, isosceles triangle, or if it's a semicircle? I don't know what the object is, but I know the area. we always take infinite sums of areas, right? Just area formula where maybe it has to do with a base length. So it's like 1/2 my base length squared for an isosceles right triangle, or a base length squared for a square, right? Or 1/2 pi r, which is a diameter divided by 2 squared. But in this case, the area of whatever the object is actually given to us by this formula at a certain x coordinate. You literally just take an infinite sum of this area formula. That's an area formula. We take the antiderivative of x plus 3. We'll do this a couple times. Oh, we did it on differential equations. It's x plus 3 to the negative first, so it's log x plus 3. We'll see, we don't need the c from 0 to 2. We get log 5 minus log 3. Right, but do not evaluate. So this is great. You hadn't seen this on your tests because I always ask you to find the answer. It's easy to grade. But we just want to write but do not evaluate an integral expression that gives the volume of the solid when r is rotated around the line y equals 6. Okay, so let's remember how to do this. So when we're revolving things around a line, we got to remember that the revolve creates something like circular. What we take is a rectangle, revolve it, and it becomes a skinny cylinder. Right? And we got two sets of cylinders here. These red cylinders, which would go to the outside, and then these blue cylinders, which would go to the inside. And if you think about it, if I can add up all of these red cylinders and their volume and subtract all of these blue cylinders and their volume, I'd get the volume of this spun object. Okay? Well, it's a rectangle spun creating a cylinder. What's the volume of a cylinder? You got to remember this. The volume of a cylinder is pi r squared h. Now, all of these skinny cylinders, the h is either dx or dy. Now, how do I know if it's dx or dy? What's skinny about this line? There is a y distance, but there's very, very small x distance. So I know for this situation it's dx. So I'm going to do infinite sum of the red cylinders, pi r squared h, and then I'm going to subtract an infinite sum of my blue cylinders, pi r squared h. Now, what is the radius? Well, the radius is from the middle to a top, or the middle to a bottom. Here, it's easy to do the middle to the bottom because the bottom is the cosine function. So the middle to the bottom is 6 minus g of x. And then for the blue, the middle to the bottom, which is the radius, is 6 minus the h of x function. And you are done. You don't have to write in the formulas for h or g because they're defined here. And you don't have to evaluate this. It would obviously be very, very tedious. You wouldn't be able to do it by hand. So you're done here. So that's great for these. We just leave it like that. Now let's go ahead and look at the scoring guidelines. All right. Good. 16 minus 4/3 is 44/3. That was worth 4 points. Woo! 1 point for the correct integral. 1 point for the antiderivative of this piece. 1 point for the antiderivative of every single other piece. 1 point for the answer, which could have been left like this, but I was just like simplifying some simple stuff. Okay, ends up being 12 plus 4 minus 4/3. Look, part B, it's just the antiderivative of the area. Integral answer, log 5 minus log 3. Part C, they like to have it combined, so it's pi outside r squared minus inside r squared, but that's just 3 points. The limits and the constant 6, the pi r squared. Yeah, like that's how you get your points. It's like 0 to 2, pi blank squared, having 6 kind of incorporated. That's how you get your 3 points. All right, next one. (2015) number 2. Been a while. All right. We got R and S. It's a number 2, so that means it's a calculator. Let R and S find the sum of the areas of the regions of R and S. Well, we unfortunately need to find this intersection if we want to maybe do all the problems. So let's go ahead and get our calculators out. Let's graph R and S. So I got 1 plus x plus e to the x squared minus 2x. I have x to the 4th minus 6.5 x squared plus 6x plus 2. They intersect at 2, 4, and they also intersect at second calc intersect. (1.0328). That's saved as x. Is it also saved as y? Whoa, look at that. That's nice. 2.4011, that was saved as y. That might be useful if we were doing things horizontally, but we're not. So this is 1.0328. Now, you could have this split up and go from 0 to 1.0328 of top minus bottom. It's the x to the 4th g minus the f. Or, and then add from 1.0328 to 2, a new top minus bottom, which is f minus g. Or 0 to 2, making sure my heights were positive, we could do either minus the other in an absolute value. You'll get the same answer. I'm not going to type in both. If you did it by yourself and split it up, good for you. You'll get this answer. Oof. X to the 4th, I'm going to do g minus f minus 6.5 x squared plus 6x plus 2 minus the quantity. Make sure you put parentheses. 1 plus x plus e to the x squared minus 2x. Close parentheses, dx. It might take some time actually to do it. (2.004). Round and truncate to 3 decimal places. The region S, okay, we need this value. As cross sections perpendicular to x-axis, they're squares. What's the volume of the solid? So squares is the side length squared. I'll take an infinite sum from this 1.0328 number to 2 of these base lengths squared. The base lengths are the f minus the g function. So let's see, x is still the 1.032 number. Good. So math 9, x to 2 of f minus. It actually doesn't matter because we're squaring it. If you put g minus f, you'd still get the right answer, and they couldn't mark it off because you are correct. But let's just be proper. So f, you don't need in parentheses 1 plus x plus e to the x squared minus 2x minus x to the fourth. This is in parentheses minus 6.5 x squared plus 6x plus 2. Close your parentheses. 1.006 or 1.007. The vertical distance between f and g in region S. Find the rate at which h changes with respect to exit when x is 1.8. So what's the vertical distance? Like, it's the top minus the bottom, right? So we got f minus g, h equals f minus g. I want h prime at 1.8. That's f prime minus g prime at 1.8. I'm not going to take the derivative. I'm just going to use my calculator. And I'm going to take the derivative using my calculator of f minus g at 1.8. So 1 plus x plus e to the. This is just so annoying to plug in. I feel like there are ways to do this a little bit quicker, but whatever. Minus g x to the fourth. Minus. It does matter the order in this situation because we're looking at derivatives. We flip flop the order. The derivative should be different. Should be. I feel like it's going to be the opposite. At x equals 1.8. 7.5122. The distance is increasing. That makes sense. At 1.2, we're here. The distance is increasing between the two. All right, let's see how we did. 2015, number 2. Four points going from 0 to A and then A to 2. It's a little soft. Absolute value gets you that value 2.004. I must have typed something in wrong. 1.0328 to 2 f minus g squared. 1.283. I got 1.006. What happened? 1 plus x plus e to the x squared minus 2x. X to the fourth. Did I not square it? Oh my gosh. Classic. It's like there's so much to type in, you forget the key thing, which is the side length squared. So I would have gotten I would have gotten everything but the answer because I had everything correct. Let's see how many points I would have gotten. 2 points for the integral. I would have gotten 2 out of 3 because I didn't type it in right. H f minus g. Considering h prime, I got a point. Getting the answer. What the heck? What? Negative 3.812? X to the fourth minus 6.5 x squared plus 6x plus 2. Now that's right. What the heck is wrong? Oh gosh, that's wrong. squared minus 2x. This is crazy how I'm showing you guys like if you rush through things. And look, I even thought I should have looked at the graph. I even thought that the picture made it look correct by convincing myself. All right, don't rush through things. Type things in carefully. Lesson learned. I'm not doing so well so far. Next question. 2014, number 2. All right, we did this in class. It is a calculator question. It used to be guaranteed like a calculator question. No longer. They're like applying it more. They're making it more difficult. But if I revolve this around the line y equals -2, the I'm not going to draw it, but the red cylinders would go to y equals 4. The radius would be 6. It would be 4 minus -2. And then the blue cylinders go to this bottom function. The blue cylinder's radiuses, which would be the whole, would be the function f of x minus -2. So for part A, I'll do it right here. Again, infinite sum pi r squared h. I have to find the intersection between those two because I'm going to start it at 0 where they first intersect, and they end at. I think it's at 2.3. Y equals 4. Y equals x to the 4th minus 2.3 x cubed. Type it in correctly. Plus 4. Yo, second calc. Intersect this guy over. Yeah. Yeah, 2.3 on the dot. That's nice. So 0 to 2.3 pi. The outside radiuses are 4 minus -2. That's the top minus the middle. Squared minus integral from 0 to 2.3 pi. We got our f of x minus -2 squared. So let's figure that out. I think it's like 98 point something. I'm going to do it all at once. This is how they usually have it on scoring guidelines. Factoring out the pi needs to be factored out. Math 9, integral from 0 to 2.3. I'll have my outer r squareds minus my inner r squares. So that's 6 squared, that's 36. Minus my inner r's are the function, x to the 4th, minus 2.3 x cubed, plus 4, minus -2, that's adding 2, squared, don't forget that. So 98.867. All right, we got an isosceles right triangle with a leg R, with a leg in R. So here's my leg in R, and I have a triangle popping out of it. I need to take an infinite sum of the areas of those triangles. Area of the triangle is 1/2 a base length squared. So in this case, I do use the area formula, and the base length is top minus bottom, 4 minus the function. You don't have to write down the equation. It's just like takes up too much space. Now, 4 minus the function squared is the same as the function minus 4. Just be careful. If you're going to do 4 minus the function, make sure you use parentheses when you're subtracting. 0.54 minus, in parentheses, the function x to the 4th minus 2.3 x cubed plus 4. Close, close. That's my radius squared. 1/2, not radius, it's my base length, 1/2 base length squared, 3.573. And then the vertical line divides the region into two regions with two equals areas, right? But do not solve an equation involving an expression. So this is the classic find the x equals k, but we don't have to find it. We know that like an integral from 0 to k of my top minus my bottom, that has to equal half the overall area. Now, we haven't even found the area. You don't have to find it. You could literally say half the overall area is half of 0 to 2.3 of 4 minus f dx. That's fine. There's an expression, an equation with integrals that we can solve. What else could you have done? 4 minus f dx, you should probably write f. That's f dx. You said 0 to 4 equals, 0 to k equals k to 2.3. Like the right half equals the left half. Okay, they don't ask you to find k. That's nice. I always ask you to find k because it was the only way that I knew that you knew, like for our first question, you have to take an antiderivative when you're getting rid of an integral. You don't have a calculator. So Isaac Newton, you have to take an antiderivative. So let's look at 2014 scoring guidelines. Two. All right. Yep. 4 points. One for an integral, one for our limits, one for our answer. The stuff like the pi, r squared is like kind of the points there. 1/2, 4 minus fx squared, 3.5. Okay, 3 points. And then the final one, area of one region and equation. I mean, yeah, they did the 0 to k, k to 2.3. You could have done 0 to k is 1/2, 0 to 2.3, you know. It's easy. If you guys see questions like this on the AP test, it's like, yeah, it's easy. Because the AP test seems like it's getting harder every year. 2014, number 6? What? That's a differential equation. No, get rid of that. 2013, number 5. I might give you another one. Or maybe 5's enough. Yeah, it's a good one. Another no calculator because it's a number 5. Find the area. All right, I mean, you can see they intersected 0 and 2, and that's nice that they gave you that. I wouldn't want to solve that. So you gotta have the correct setup. You gotta have the correct antiderivative. The x squared is the open and upward function. Parabola, the cosine, oscillating. You have to kind of figure that out, like x squared, opening upward, parabola. So top minus bottom would be the cosine minus the x squared function. Or cosine 1/4 pi x, pi over 4x, minus 2x squared minus 6x plus 4. Great. That's just the setup. You have to take the antiderivative. You have to plug in 0 and 2. So here we go. I got 4 sine. I got 1/4 pi or pi over 4x. But then I got to multiply by the reciprocal of this. So I need to multiply by 4 over pi, which is why I get 16 over pi. minus, keep it in parentheses. You can distribute the negative if you wanted to. But I don't know. But actually, it's easier in this case to distribute the negative, to be honest. That way we don't have to worry about too many parentheses. So plus is negative 2/3 x cubed. This is 3x squared. This is minus 4x. You can have a plus c, but you don't need it. You're ready to plug in 0 and 2. Now, the next step, you can just leave. They actually have to accept the sign of pi over 2. But you know that's 1. And thankfully, when you plug in 0, you get 0. I mean, you can leave it like this. Probably would want you to put that the sign of 2 is 1. You need to know that for the multiple choice portion. But this is the answer. I mean, I don't even want to simplify this much more than that. I mean, I have pi in the denominator. It's like, let's just leave it. This is good. This is fine. So let's not panic about things. All right, revolving around y equals 4. Now, you know what we haven't seen? Like revolving around any vertical regions. So just be careful. It's like, I feel like we're due with that. But, all right, I don't have to draw everything as long as you understand that the outside goes to the parabola, the inside goes to the cosine. You get to write but not evaluate. That's nice. So I can do it right here. Here's where I'm going to put part B. Again, it's a radius that's a y distance, and then the height is going to be a very skinny x distance. So pi r squared h is dx. R is going to be a middle minus a bottom. So 4 minus what's the bottom? It's the f function. So just put f of x, don't write it down. And then subtract the volume of the whole, 0 to 2 pi. It'd be 4 minus the cosine function g of x. Okay, same thing for C. We get to write but not evaluate. I've seen sometimes they ask you to evaluate. When you have to evaluate, sometimes you can, anti-do the chain rule. Sometimes you'll have to square things to simplify. Just be careful, okay? But here, we're putting a square inside of region R. So I need a base length squared. So 0 to 2 base length squared. It's very easy because we don't have to like type. Sometimes easier to do a no calculator area volume question because we don't have to type so much stuff into our calculator. It doesn't even matter which one you put, top minus bottom, bottom minus top, because you're squaring things. Isn't that nice? I think area volume should be more no calculator. They're easier to calculate. There's less stuff to type into your calculator. What do you mean? Because so often people square, and we don't ask them to know the cosine squared and sine squared. Right. Oh, you're saying right, but no. Which is great. You get a no calculator question with cosine in it, then you know they can't. They're not gonna. Yeah. So my question is, did you know? Is this on AB? This is 2013 AB. Oh, okay. Did you realize that on number 1, it was not, they were not asking you to approximate the derivative at the edge point, it was 2.25. I know. We're just right on a point, which means you had to use 2. It's 2 and 2.5, and they asked you about 2.25. And we always read it as 2.5. What? Are you serious? Yeah. They just told me. I was kind of just like going off, like, I don't understand why they do that. Doesn't make it any more interesting, or doesn't make it more tricky. Well, no, that actually helps you. Yeah. Yeah, it's 2.25. Okay. The more I look at the test, the more I'm like, okay, 2 of the problems are hard. 2 of the problems are hard. The other 4 was pretty straightforward. And they send it multiple. So it sounds right. All right, let's see how we did on this. 2013. Coffee problem. It's a hot coffee problem. 16 over pi minus 4/3. 16 over pi. I guess that's minus 4/3. Whatever. You're good. 1 point for your integral, 2 points for your antiderivative, 1 point for your answer. That's my answer. I get credit. Part B, 2 points for your integral and the stuff that goes in it. 1 point for the limits and the constant, the 4 minus. Good. 4 minus f squared, 4 minus g squared. 0 to 2. Doesn't matter if it's g minus f or if it's f minus g because we're squaring it, but you know, just be careful. It's probably best to do g minus f. Yeah, g minus f. Or whatever. I'm right, because you're squaring it. Can't get it wrong. Okay, 4 then 3 then 2. All right, what's next? (2012) number 2. I might try to find one more for you. This is great. Find the area of R. So this is a calculator question because it's number 2. Ready? 2 ways to do it. You find that intersection. And then you got to realize there's 2 tops. If you're doing vertical things, you got to do that plus different that. I'll show you another way to do it. This is like a question I got you ready for. Back when we were learning this stuff, you had this on your homework. So we got log x, 5 minus x. Second calc, intersect. Go to the right, that way it uses it. All right, that's an x, so that's a y. It's saved as x, and it's saved as y. It's fantastic. So I'm going to say x, maybe say a. A is 1.306, 3.693. A is 3.693. B is 1.306. Okay, cool. So you can either do integral from 0 to a of the log x function plus a to, this is helping you, 1, 2, 3, 4, 5, a to 5 of the 5 minus x function. Type that into your calculator. Or go horizontal. The horizontal will help you later in this question. Right minus the left, dy. We're going from 0 to b, a bottom to a top of the right x, x right minus x left, the x right, x equals 5 minus y. The x left, x equals e to the y. Either way you do it, you're going to get the same answer. I'll show you. I can type it in pretty quickly because 0 to x would be 0 to a log x plus a to 5. It's 5 minus x. That is 1.985. It's going to be the same as, oh, I made a mistake. It's not 0. It's 1. I start at 1. 1. This starts at 1. Oh, look at that. This would have been a good thing to do to check. $2.985. Now, if you do math 9 of 0 to y value, 5 minus y minus e to the y. You get the 2.985. Don't put both ways down though. Just get it right. All right, perpendicular to the x-axis is a square, right? But do not evaluate one or more. You need more than one. Because we're putting squares, we got to go from 1 to a and then a. So from 1 to a, I need my side length squared. And then from a to 5, I need my side length squared. It's really just the same as this, only with the squared. So that's easy. But then part C, the horizontal line y equals k splits this region into two equal areas, right? But do not solve an equation. So you can go 0 to k of 5 minus y minus e to the y dy is 1/2 my area, 2.985. You don't even need the number. You literally could just have this written down. You can go 0 to k to b, whatever floats your boat. I'm going to put the 1/2, 2.985. Just I would use probably the entire decimal. That's it. 3 parts. Let's see how we did. I'm going to end the video there. Let's just do 5 problems. Decent review. 2012. Okay, 2.985. You could either do it 0 to b and 1 to a to 5. Look at that. They did a and b too. 1 to a to 5, squareds. 0 to k, 1/2, 2. Yeah, they did the exact same way. So 3 through 3. Yeah, we're going to end it there. The most recent test that was just given, 2021, they kind of had an area volume. And oh boy, was it not like any area volume problem seen. This is tricky. Ways to get things right, but tricky. The rest of the test is not bad at all. About 1 and 3 were pretty brutal. Anyways, that's it. That's my last video. I'm not making another video the rest of the year. I'm done. I'm toast. It's been real. Later.